This is the best one yet. I'm going to give it a 10. I think I'm going to take one more tiny bite. I'm glad that's the end of my data gathering. I'm too full to go on. It might not look to you like I'm doing statistics, but I am. You see, I've often wondered when I'm in the bakery whether price is an indication of quality. Is the most expensive chocolate cake always the best? Is the best chocolate cake always the most expensive? The statistical question I want to answer is, how is a cake's quality related to its price? To test this, I asked a friend to buy me 10 chocolate cakes of equal size. He gave each cake a number, noted its price, and then sealed up the classified information. Then came the fun part. I tasted each one and gave it a rating from 1 to 10, with 1 being inedible and 10 being out of this world. Okay, now I have 2 pieces of information on each cake, the quality rating and the price. I want to know how strong the relationship is between these two. To figure this out, let's plot each cake according to price and rating. We can see that the variables are closely associated. As the price of the cakes goes up, so does the quality rating. But I don't know whether price determines quality or quality determines price. So my decision about which variable to put on which axis was arbitrary. We could just as easily have switched the axes, and the relationship would have been the same. Price and quality go up together. The pictures give us some idea of how the variables are associated, but I want a more precise description. And that's exactly what we'll learn in this program, with a statistical technique called correlation. The number that measures correlation is called the correlation coefficient, known as R. R gives us a measure of the strength and direction of the relationship between 2 variables. R is always a number between -1 and +1. The closer R gets to 1, the stronger the association it describes. Notice that the associations here are positive. As one variable increases, so does the other. +1 is a perfect positive correlation, which means that all points fall exactly on a line. In real data, perfect correlations are extremely rare. Again, the closer R gets to -1, the stronger the association between the 2 variables. But this time, the association is negative. As one variable increases, the other tends to decrease. Remember that these were the data from my chocolate cake experiment. And the correlation is plus 0.8. That's a strong positive correlation. I do have pretty expensive taste, I guess. In this program, we'll learn how to use the basic facts about R to interpret correlation. In addition, we'll learn how to derive the correlation coefficient. And we'll learn that when a regression is performed, correlation can be used to judge the usefulness of that regression. In addition to the important chocolate cake issue, correlation is at the core of many statistical questions. For example, what is the relationship between student performance and school budgets? Between a baseball player's salary and his home run totals? How closely correlated are identical twins on physical characteristics or personality? This twin question is particularly interesting. Let's look at it in more detail.
At the annual Twins Convention in Minneapolis, there's no shortage of activities. There's a look-alike contest, a talent show, and a visit to the ball game to cheer, appropriately enough, the Minnesota Twins. The fact that these identical twins look and act so much alike should not be all that surprising. They have identical sets of genes, and they were raised together in the same environment.
You're gonna hit the 1 ball?
Mark Levy and Jerry Newman are also identical twins, but they were separated at birth and adopted by different families in different states. They remained separated until a friend of Mark's arranged for a surprise meeting. Mark recalls his first impressions of his twin brother.
He's big like me. He's got a big nose like me and glasses like me. And he was wearing a baseball cap, and when he pulled the baseball cap off, I'm like, oh, hell, he's bald like me.
And that's when I said, Mark, I think Jerry
Is your
your
brother.
brother.
And I said, no.
Besides their physical resemblance, which would have been even stronger before Jerry lost some weight, the two have a lot in common. At the time of their reunion, Mark installed burglar alarms for a living. Jerry installed fire alarms. They're both bachelors with a passion for motorcycles and beer. Both hold a beer can with the pinky on the bottom. It keeps it from slipping, they both explain. And both are captains at volunteer fire departments, a remarkable coincidence to outsiders, but not to Jerry.
Well, I guess I always wanted to be a fireman. And then I find out that my brother's a fireman. It's not strange. He's got to be a fireman. Only because firemen aren't made. Firemen are born.
Does that mean that being a fireman is genetic? Jerry and Mark would make you think so. Since they were raised in different families, the most likely explanation for their similarity is their identical genes. Seeing an opportunity to study the relative roles of environment and heredity, University of Minnesota psychologists have been collecting data on identical twins raised
And
apart.
then you decide who's going to go first.
You.
This recently reunited pair is undergoing a week of intensive testing. The data gathered will be added to dozens of twin pairs already studied.
These little ring fingers here are very...
The question is, how similar are the twins? Or, in other words, how closely correlated are they for certain traits? In addition to physical characteristics, brainwave activity is also studied. Here, response to the anticipated stimulus of a balloon popping is being measured. Personality and intelligence tests are also administered. Comparative data are gathered for identical twins reared together on the same traits. The logic of this process is explained by the director of the study.
In the case of identical twins reared apart, the only reason they ought to be alike is that they share genes in common. So the measure of correlation or similarity between them reflects the effects of genes. The contrast is identical twins who are reared in their own family. There are two major reasons why they should be alike. One of the reasons is common genes or heredity. The other is common family environment. Consequently, you can compare identical twins reared together and identical twins reared apart, and the difference in the size of the correlation tells you the influence of the common family environment. So by simply comparing two correlations, you get a great deal of information.
Let's apply what we already know about correlation to this study. This is what a scatter plot for heights of identical twins raised apart might look like. Each point represents a twin pair, twin A on the x-axis and twin B on the y-axis. But there's a problem here. Since the twins are identical, the decision about which is twin A and which is twin B is arbitrary for each pair. To deal with this problem, a special kind of correlation is used. There are many types of correlation in statistics, but fortunately we can interpret them all the same way. Here the points are tightly clustered about a straight line. R equals 0.92. This high correlation suggests that genetic influences are quite strong in determining height. It's not really surprising that physical characteristics are so greatly influenced by heredity, but what about mental traits? This is a scatter plot illustrating the results of a personality inventory given to a set of identical twin pairs raised apart. The relationship is obviously not as strong as the one for height, but here again the points tend to increase together. The correlation is 0.49. Many psychologists have long believed that personality is almost completely the result of environmental influences. So while 0.49 is much lower than the correlation for height, it's a surprisingly high correlation for personality. What's even more surprising is that the correlation for twins raised together is almost the same, 0.52. Let's return to the center to see how these findings were interpreted.
The correlation between the twins raised together was the same as the correlation for the twins raised apart. This suggests that whatever is responsible for the similarities in personality between identical twins is not the influence of the shared home environment.
Does this mean that our personalities are already fixed at birth? That genetics are more important than environment in shaping who we are? Perhaps these aren't the right questions to ask.
That's like asking what's more important in building this building, the bricks or the blueprint. They're both important, and you can't do without either one. What I think our research is indicating is that genetic effects are important in the whole construction of the human psyche to a surprising extent, much more strongly than people had thought previously, but that to a large extent the genes do their work by influencing the kind of environments that we have, the way the world reacts to us, and the kinds of environments that we seek out.
The study of identical twins, in which correlation is an important tool, has led psychologists to reformulate the nature-nurture question. The key question is becoming how nature works via nurture to make us who we are.
With twins and with chocolate cakes, we've gotten some sense of what different correlations look like. Let's take this one step further. How strong is the correlation represented here? How about here? And these? I could use a computer to figure out these correlations, but say I want to do it myself to try to understand where the correlation coefficient comes from. It all starts with this formula. I know